Okay, so 7.5 deals with solving equations containing rational expressions. So essentially, it's just dealing with equations that have fractions in them. So the way that we're going to work these is we are going to get rid of the fractions, which should excite many people because y'all don't like fractions anyway. So what we're going to do is we're going to clear the fractions. So when you have an equation that contains fractions, your goal is you want to clear all fractions. The way that we do that is that we multiply all terms by the LCD. So we identify the LCD of the equation, and then we'll multiply every single term by that LCD, okay? So when we look at this particular example we have here, I have denominators of 2, 3, and 6. So what is the LCD for 6? For 2, 3, and 6, the LCD for those denominators would be 6. So 6 can go into all three of them can divide evenly into 6. Or using the rules from 7, 3, 7, 4, you pull out all your factors, right? So 2 and 3. So LCD would be a 2, check, check, and a 3, check, check, which gives us a 6. Okay? So we want to clear the fractions by multiplying all of the terms by that LCD. So let's see what that looks like. So I'm going to multiply everything by 6. Okay? All right. So this is where we got to know what we're doing. The point of clearing the fractions is to get rid of the denominators. That's what we mean when we say clear the fractions. Multiplying all of the terms by the LCD is what's going to allow us to get rid of those denominators. And so what's going to happen is that denominator is going to cancel with that LCD. So when I look here at 6 times the x over 2, so I'm going to just show you over here in a little bubble what's really happening, and then we're going to just do what we need to do. So it's like doing 6 over 1 times an x over a 2. And so we want to know, what does that mean? Well, there's a 2 inside of a 6. So if those 2's cancel each other out, what's left? 3x, right? 3 times an x. Here we have 6 over 1 times 8 over 3. So what's that mean? Well, inside of the 6 is the 3, so the 3's would cancel each other out, which would leave us with the 2 times the 8, which would leave us with a 16. And realize these denominators are just 1's. Then the last one is a 1/6 times a 6, so which would just give us a 1. So we want to understand, we don't have to do all this side scratch work. We can just understand what factor cancels in the LCD with that denominator. So if I cancel the 2 inside the 6, it would leave the 3, which gives me 3x. Plus, I cancel 3 here, and the 3 inside the 6, it would leave a 2. Equals 6 cancels with 6 will leave a 1. Now I have an equation that looks like chapter 2 that I can solve. So once you multiply all your terms by the LCD, you would then be able to solve what's left. And then you're going to check. Okay? So I have 3x plus 16 equals 1. So remember that you have multiple ways of solving, because you have the way you solved in chapter 2, and then you have the way you had to learn how to solve in chapter 6. Meaning, do you have to factor? So when we look at this equation, there's no exponents other than 1, so we can just solve by isolating the x to one side. So I'm going to subtract 16. Divide both sides by 3. X equals -5. Done. And then, of course, you can always plug that value into the original equation and check to see if you get a true statement. Okay? All right, let's do another one. Okay, so here we have a second example. So we have x minus 4 over 2 minus t over 3 minus t minus 3 over 9 equals 5/18. So we have an equation and it has fractions in it. So basically, your mind to say, I got to figure out my LCD and multiply everything by that LCD, and then I'll solve, okay? So looking at the denominators, we have 2, 9, and 18. So the LCD is going to be 18. So we're going to multiply every term by 18. Okay, so when I do that, what happens? Well, the 2 cancels with the 18 and would leave a what? A 9. So what's that look like? 9 what? Times x minus 4, right? Make sure we understand this is, well, this is an x, not a t. All right, so put those in parentheses. So then a minus, because it was a minus here, I'm just bringing it down. So then 18 multiplies to the second fraction. The 9s would cancel, which would leave a 2 there. So minus 2 times x minus 3 equals, the 18s cancel and just leave a 5. So now we just have a basic equation that looks like chapter 2. So what's happening is now you're bringing back everything. So this chapter 7 is essentially bringing back everything from the beginning almost. All right, so we have to distribute here. And now we're going to combine like terms and try to solve. So when I combine like terms, I have 7x minus 30 equals 5. So when we look at this, there's no exponents other than 1 on that x. So therefore, I can just isolate my x. I don't have to factor anything. So I'm going to add 30 to both sides because I know how to solve an equation. So I'm going to just tell you if you're looking like, oh, why are you plussing it? Because it's a minus 30, right? So you got to be able to remember all your stuff from previous sections. So 7x equals 35. So then I have 7 times x, so I need to divide both sides by 7. So x is equal to 5. And we're done. And then you can substitute that in to check. Okay? All right, let's look at another one. This one is back there. All right. Erase this. Okay, so here we have 3 minus 6 over x equals x plus 8. So we have an equation that contains a fraction. So remember that you have to clear your fractions. So you have to find the LCD and multiply everybody by the LCD, right? All terms. All right, so in this particular equation, I only have one denominator, and it's the x. So that's the LCD. So the LCD for this particular example is x. So I'm going to multiply everybody by x. So 6 over x times an x, the x's cancel. X times x is x squared. 8 times x is 8x. So remember that you're multiplying everything by the LCD because anything that has a fraction, that is a fraction, the denominator needs to cancel with that LCD. All right? So when I look at my next line, 3x minus 6 equals x squared plus 8x, I have no fractions left. So now I'm good to go. Now I can solve either using chapter 2 stuff or chapter 6 stuff. So when I look at this equation, I see an x squared term. So automatically my mind says, oh, you're going to have to factor this problem. So after we clear, our goal is to solve. So what encompasses solve here? Well, it's solve, but I'm going to have to solve by factoring. So now all your rules from your chapter 6 has to come into play now, right? So what's that mean? It means if you didn't learn it before, you better learn it now, or you're not going to get out the class. I'm just going to be honest with you at this point, right? So we have to make a decision for ourselves. So 3x minus 6 equals x squared plus 8x. So when we are solving by factoring, the rule says that you must get everything to one side. You must make the equation equal to 0. And let me explain to you what you want to do. You never want the squared term to be negative. Therefore, my x squared, that's my boss right there, because he is my leading term. So because he is already positive, everybody else is going to move to his side. So I'm going to move the 3x by subtracting it, and I'm going to add the 6. So when I do that, I get 0 equals x squared plus 5x plus 6. I'm going to rewrite it because I like my 0 in the back and not the front. Just because, yes, it looks so much better. So now I'm looking at x squared plus 5x plus 6 equal to 0. Now I just need to factor it and then solve. And again, it's just your rules from chapter 6. So I would factor that trinomial. So factors of 6 that'll give me a 5 would be a 2 and a 3. Once you factor, you set each factor equal to 0. I did not need those parentheses. So x plus 2 equals 0. I subtract 2 on both sides. I get x equals negative 2. X plus 3 equals 0. I subtract 3. I get x equals negative 3. So my answer is negative 2 and negative 3. Now, this problem was different. This original problem was different from the other two examples because my denominator was an actual variable in this particular example. So one thing about fractions that we did in the 7.1 section was we learned something about being undefined, right? And what makes the fraction undefined is if there's a 0 in the denominator. So when your rules tell you to check after you solve, what they really want you to do, you can always check your solution, of course, but they want you to check the solutions to see if any of the solutions that you got would make you have a 0 in the denominator. So since our original problem here had a denominator of x, none of my x's that I got x equals negative 2 and negative 3. Neither one of those x's would make a 0 denominator, so we're good to go. So there's no issues. We have nothing that needs to be taken out of this particular solution set. So when we learned that in 7.1, this is where that information about identifying values that would make it undefined is going to come into play because we are solving now. So if we get any values of x that will make the denominator in the original problem equal a 0, then you will have to throw that solution out. Okay, so let's keep going. Here we have this equation, 2x over x minus 4 equals 8 over x minus 4 plus 1. So the LCD is what we need first. So in this particular problem, you look at your denominators, x minus 4. Right, because we account for each one. So the LCD is x minus 4. So we're going to multiply each term by x minus 4. Don't be lazy. You have to write it out. So then when I go through, x minus 4 cancels with x minus 4. Leaves me with a 2x equals x minus 4 cancels x minus 4. 8 plus... This would just what? Multiply or distribute. So 1x minus 4. Alright, so now I'm just going to combine like terms and see about solving this. I have nothing with exponents other than 1. So when I combine like terms, 8 minus 4 is a 4. So I just need to get my x's together. So minus 1x on both sides. So x equals 4. So we get x is equal to 4. Now, when we look at this, remember your last step says check it. So when you check it and you go back up and you plug that 4 in for the x, when you look at the denominator and you put that 4 up there, so like if I do 2 times 4 over 4 minus 4, just from you doing this first fraction, you get 8 over what? 0. Right there is where we're done. Once you see that the 4 plugs into the denominator and creates a 0, what does that mean? Based on the 7.1 information about values that make it undefined, that value cannot be included in the solution. So x can never equal 4, because if x is equal to 4, it's going to create an undefined outcome. What does that mean? That means that 4 is not a solution to this equation, because a solution means you can substitute the value into the equation and create a true statement back. That does not happen here. So because if I plug 4 into the denominator, I get a 0, which makes it undefined. 4 is not a solution to this problem. There's no other options, which means there's really no solution to this question. No solution. Okay? All right, let's look at another one. Okay, so here we have this equation. X plus 14 over x minus 2 equals 7x over x minus 2 plus 1. So we need to identify the LCD. So the LCD is x minus 2. Okay, so what do? I want to take my x minus 2 and multiply it to every single term. Because remember, right now my goal is just get rid of those fractions. But everybody has to multiply to the x minus 2. So I multiply x minus 2 to everybody. So first, this would distribute here. So x squared minus 2x. And the second one, the x minus 2's cancel. So just plus 14 equals x minus 2's cancel. 7x plus distribute 1x minus 2. So I went through and I cleared all my fractions, right? So I multiplied everything by the LCD. So now I don't have any fractions, so I have an equation that I know I feel comfortable working with. I do see a squared term there, so I'm thinking I'm going to have to factor this problem. What's that mean when we factor? It means you have to get everything to one side. So let me simplify this a little better, because on the right side I have 7x plus 1x, which is 8x. So I'm going to have to make this equation equal to 0, because in order to solve by factoring, it has to be equal to 0. So I'm going to get everything to the same side. So I'm going to move my 8x, and I'm going to move my plus 2. So minus 8x because it was positive, and then I'm going to add my 2 because it was originally negative. So x squared minus 10x plus 16 equals 0. So now I'm going to factor. So I need factors of 16. That'll give me a 10, 2, and 8. So I do my 2 sets of parentheses. I need a negative 10 and a positive 16. So 2 negatives. So minus 2 minus 8. And that would give me 0. So x minus 2 equals 0. X minus 8 equals 0. I solve each one. I get x is 2. And I get x is 8. So I have my 2 answers. I go back to my original problem to check to see if any of these solutions need to be thrown out, because it could create a 0 in the denominator. First thing I do is I look at the top. If I plugged in 2 into the denominator, 2 minus 2 is what? 0. What's that mean? I can't use 2. 2 cannot be part of the solution. So the answer is just x equals 8. Now again, plug in both of them into your original problem to actually check, right? And you should get a true statement back. I'll just check the 8 for you just because, just to remind you how to check. You plug it in to everywhere that you see an x, because we're saying that's what x is equal to now. So 14 over 6 equals 56 over 6 plus 1. So then you would add these fractions up in order for you to identify whether they are equal to each other. So we get 31 over 3 equals 31 over 3. I put it in a calculator because I don't have time to be adding up all them fractions in my head. So I just use a calculator to check, which is what you should do too. So I get true statement, right? So that's what a solution is. It means you can substitute the value into the original equation and get a true statement back. And when we substitute in the 2, automatically we plug it in the denominator. We get 2 minus 2 is 0. That's automatically out. And we know that from 7.1 with identifying any value that would make the expression undefined. Okay? So that's solving equations that contain rational expression.